So, hi everybody and welcome back. This is a C++ tutorial series for absolute beginners. This is video 168, and in this video we continue, of course, with classes. But before we can continue with classes, where we have so much to talk, we need a little repetition about variables, because I want create variables with our class, which we talked in our last video. And the reason for that is because I want to introduce reference and pointer creation with our custom class. We have not talked about this one. But before that, let's repeat fast what I did in my last video so you know what I'm going to do. I have created again my namespace house. In that we created our class. I created here my big house class in this namespace, and my big house class, you can see it's very simple, only two variables in it, one function which prints out my house name. So that's it. And I have here two constructors, and in my last video we talked about delegate constructors, so you know when you see a constructor like this what this is. So can you see it? Here we have a constructor, but important is when you see something like that. Here I use the same name here again, and when you see something like that, it's a delegate constructor, which means this one is calling another constructor, and we are not allowed to define here as initialize variables, for example. It's not allowed here at this place, but it is allowed in the place where this delegate constructor is called. For example, in my case, this is called here. This is just this one here on top. And here I'm allowed to initialize variables, and we talked already about this, and you know this. And you know also what happens when we use a delegate constructor. This one is calling first this one, then this one is finishing its body, and then it's returning back to this point, and then this one is finishing its body. Important is I have not defined here a default constructor, which means I have to use one of these constructors. I don't have to use this delegate constructor. I can use also this one here if I want. This one is just if you want to use a delegate constructor who has here anything in the body which you want as well. Then you call something like that, and that's it. That's my little class. It's very little, and there is so much to talk about classes, but in this video, like I said, we want to create now variables with this class here and introduce here references and pointers and how we make this and so on. Right? So, but before we do this as well, let's make a fast repetition, and you can see I already prepared here a little bit code, and this code you should already know, and that's why we make this a little bit fast, and I explain it, and I will add some more information and see what we can do. So first of all, here at start I called it normal, our normal declaration of a variable. So we start, for example, this example I used all time in my tutorial. You can see it's just a int, my telephone number, and then I assigned an initial value, and you see the type is int, the variable name is my telephone number, and this one here you can call theoretically object as well. But this object here, this variable name here, it will be not the same like my class here. So the question is why? Why it's not the same? Because here you have, I told you at the start that this int here is a type, and when I create a class, it will be also a type. So that's not the problem. Type is same, because in front it's a type, and you can see here the second example. This one I used also std string. This one looks more like that what we have here, by the way. For example, we have here std is a namespace, and then the class string. So you can see the string will be search, this colon, say I search this class string in std. And if I find it there, then you can use it. If not, then not. And I make here my name encoder. So far, I hope you know also. But what is again here the difference about this one and this one here? This or this one or this one and this one here. First of all, they are both types, and the difference is that this one here is, I called it a primitive type, or let's say a built-in type. A built-in type means this one was special optimized and prepared and also realized, also in technical terms, not in the same way like this one here, because this one here, there's classes which they provide us programmer to create, has some more features, which means it is not so efficient like a built-in type, which means it's not absolutely the same thing. This built-in types, this int here, is perfectly optimized, and it has also, with other words, it's just faster than what we can create in normal things because it's perfectly optimized, and the compiler is also optimized, and it is not created like this one also because it's faster. It is also not provided like this. Let's say in technical terms, it's not realized like this way. That's enough for us. If you want more about it, of course, read it in good C++. Looks like you should do anyway, because this one is a practical tutorial, not a theoretical tutorial. So use all time a good C++ book, please, where they explain all this kind of stuff in detail and more accurate. So anyway, that's there is a way to show you also that this one is not exactly like this one, or at least a little bit, not exactly. So how we can see this one, for example, but I think they have just not provided this one. This is not a really showcase, but it is more like, yes, it's not really that. But what I want to point out is we have not talked about this string so much, even we used it all time, this string type, right? Because you can see this one is the same thing like we do here. It's similar. It has a namespace that is this std. It has here this class which is in this namespace. In my case, it's the big house. It's in the house namespace. But what we have not talked here is we have all time used it this way, right? So we have just created this variable, then we have assigned a value perhaps later, and then when we printed it out, we did something like that. And you can see the outprint is just using the variable name for the int or my name. But what we have not talked about is, of course, look this, I can take this my name here. Look what I do now. My name, and then I write a dot, and this dot we learned recently, right, with classes. And you can see here a big list, and this list are most time functions, and we know now that this functions which you can see here are only public functions, and this one are operators or something like that. We can click on this one. Let's see. Yes, they are just operators, overloads. And we have to talk about this operator overloads as well, because it's very important. But like I said, we need to talk about so many things in classes. We are just at the beginning. Anyway, that's not important now. You have to know this one, what we used all time, has many functions which we have not discussed. The string class, because like I said, this is just a string, a class like we did, and they defined it. The only thing is we have not watched what is in it. We have not talked about the string class and the standard string. We will do this later after we finish, first of all the class things, so that we can understand it. Because when we dive into this one, right now they use still many things which we have not talked about, so we will not understand all. That's why I have not talked about this. But right now you should know this one has many public functions. Some of them we can use later, depends. And after we finish classes, we will understand how they even implement them when we go to these places, how we can go to this end, for example. Like I said, normally what you do is right click, go to definition, and then it jumps up. So you see here jumps nothing up, but here on the bottom you see here they found here 2 places where you can choose. Let's click this one for just fun, and then you can see it jumps here to this place, and then it defines how. And I said we are not able to understand all things because here they have a macro. We have not talked about macro, but the other things, let's say Const, we know no exception is just an attribute here, and or no exception was in this exception section where I said we have not talked about this. This means just don't throw an exception even if it's possible. And then you can see return, and then it calls this, and here is called again a macro, and here is okay, there are many things which we have not talked about. That's why we're not jumping there. All right, well, because when we jump there now, that can cause more confusion than help you. The other thing is you should know that this is possible. So I hope you understand this one so far. That's not a big deal. And here, the same thing we can try now with telephone number, and that's the point. This telephone number is actually providing us no access. So you can see I try to access this primitive number. They don't provide because there is nothing to access. You should just use it. The same, this is the problem. So you can see this one gives us it's built like a class like we built here. It gives us many options, and this primitive type here is actually not really, at least provide us not access to any functionality which we have. Because normally it can also provide us accessibility normally, but in this case it is not. All right, that's nice. I hope that's easy to understand. And let's continue now with our thing. So we see this one, you should understand. Then the output is also very important because depends on what variable we have, the output changes. We learned this, right? Reference and pointers and something like that, right? We learned this. So let's see, we have here something like a int my telephone number, then my string. I put this out. I hope you remember this is a standard output. Let's go on to the reference section. So, and I took here the same thing here, so I don't make something new. You can see the only thing what I change is I take this int again and I add a reference symbol, so to indicate that this variable is now a referenced variable. So, and we know what a reference variable is, right? And you can see here my first example, a reference variable need at start an initializer, which means if I took out this initializer, which would be normally a declaration, it's not possible, but we learned in classes we can do this, right? I can do this one, but then I have to provide it in the constructor. So I hope you remember that. If not, I make you fast an example so that you can remember it. And what I mean is here, let's me copy this one fast here to my class just for test purposes, and let me add this here. So you can see I can do here that what I can't do at the bottom, which is this one. You can see no error, but here the constructor is complaining, and you have to initialize it on the constructor definitely, right? So you have to do this here, and if you don't do it, we have a problem. And why is this here possible, if you ask? Because like I said, we will learn that a class can have a header file and a definition file, which is a CPP file, and a header file. This header file can have just something like that, and the definition, the CPP file, where you define the body, and so that must have this initializer here, this constructor with this initializer. All right, I hope you remember that. That's very important later to know, so that you don't get irritated and say, I can do this here as well. No, here you can't do this. We have here initializer value. And what is the reference doing? I hope you remember this one as well. It's similar to a pointer, but careful, it's not a pointer. It's called a reference, and use it as a reference, which means it is now using the storage place of, in my case, of this variable, which I have created before. And a reference is all time asking for an L value. And this one is an L value. I talked about this L value all time. Read this place in the documentation, how an L value is really defined, but I make it very simple and say, if you have already defined a variable, and this variable has a fixed storage place, and this fixed storage place can the compiler assign and ask, and then it's called an L value because there is a fixed storage place which the compiler knows, and the programmer can access it most time too. And that's because there are, we know also there are some R values. What is an R value again? R value was, let me print this out. So for example, if we try something like that, this will not work. This 5 here is a temporarily created value by the compiler. Temporarily means it is just created to assign, and it is called an R value. And when I hover my mouse over it, you can see initial value of reference to non-const must be an L value. So this one, yes, there was something else with const. We learned something with const that I can use this one with me, which means if I add here a const, then look what happens here. I can use that. Very strange, right? But careful, this was only with const, and the reason for that is this const this will be assigned and then made a fixed place at the initialization time. All right, so that's only possible with const this L value, but in general, not. I think we have not talked about const references so much, but I hope you get the idea that this is possible with const. But we will talk about const a little bit more detail in the future, perhaps when I find the page in CPP reference comp. But let's continue. So here in this case, we need an L value. Just think about it. Without const, it means you need a fixed place, a variable which has a fixed storage place. If you put a const, you can take anything. So you can use even at this one here, I think. So you can just write here const, and you can use as well this one here as well. That's not very important. Const can use both. And we learned also when we have in function that we use most time this const. So we don't care what it is, an R value, L value, what is paste. And most time we make this const, but to not change here this value which is comes in. But const means also you can't change. That's why it's const. And perhaps you want change it, like backward change. In my case, I want change it, so I keep this not as a const, and then I have to provide an L value. So I hope this kind of stuff you know. We have talked about this. And here I make the same thing with a class version. That was here this primitive version. Here the same thing with a class version, the same rules. And yeah, I think there is not much to talk about this one now. This is just to show you that you can do this with the class version, and we will do this in a moment here with our class. Here is the string class, exactly like our class. And yeah, let's see what I do. And here important is how we print this out. First of all, before we print this out here, how we assign values. So what was reference again? How we assign to our reference variable values. Easy, you can see it already. We can assign it just like a normal assignment. In this case here, and here my string reference, here the same thing here, because it's a string I have to assign a string value. Here is a string value. Nice. So far you should know all things. And when I will print this out, and this is also interesting how you print this out. Here you use this one, here you use this variable here, so there is no big change. But let's go to the pointer. So let's make a pointer. Interesting, we make a pointer here. So how works a pointer again? First of all, here's the primitive type. I hope you know it. We create a pointer. And when we create a pointer, you can see I have already here this address of operator about that what I want point to. In my case, I want point to my telephone number, which is this one here. It's already a fixed place. Again, it is an L value here in this case, and I want point to it. And interesting here is, careful, reference was not possible to do this one. That's why I said don't treat reference and pointers equal. Here I can do this one here. I can just declare a pointer, but if you declare a pointer, never declare it this way. This is pointing anywhere and can cause problems. All time assign null, not null ptr. It's the new version, but you will see probably in older codes null, oops, this null here, this one here in older codes, or this one here. And interesting is also this is a macro, by the way, so you can see here the color change. That was nice. Oh no, it's not coming. Like old time, when I want to show it, it's not coming. But when I hover over it, you can see this color, purple color, or what is this? Anyway, this color here should be changed, and you can see this is a macro. Macro means just, yeah, we will talk about macros later, not important right now. It is just a redefinition of something. So in this case, we use the new version as old time. If you declare a pointer and you don't know where it points, make it to a null pointer. That's important. But important is as well that you can make this one here. Yes, like this, because a reference you can't do this, and a pointer you can point to nothing. That's possible. And I hope you know this one as well. And the next thing is what I also not showed you. I think I have not showed you this one as well. This pointer can point to a reference variable. What I mean with that here, my reference number, not my reference number, my string reference, because this pointer is a string pointer, so I still need a reference which is also a string, so I need this one here. I can change this one here, not this one here, the name here, because I need a string in this case. So I can, to a reference variable, my string pointer, for example, to this one here has a string. This one is a pointer. That's why I can get the address of a reference to. And why is this possible? The reason is very simple. We know our reference must be initialized, and the reference is pointing already to a fixed location, right? Normally it is so. And this pointer will, I think I should talk this also in a separate video, because pointers, there is also much to talk which we have not talked. We have talked only about really basics, so about some start points. And here, because this variable here, oh, what's going on? I don't know. A control string, I know that was doing something. So here, this pointer, this is already initialized. I mean, it must be initialized. A reference we learned here on top, a reference must be initialized or it will be not, it's not valid, right? And then this pointer points exactly to the same place where this reference is pointing, or let's say in this case has access, right? So which means this point analyze that where this one is reference is accessing, which is this one, which means in short form for beginners, you can say this pointer points to the same place where the reference is pointing. But yeah, careful, all time, reference is a reference and pointer is a pointer. All right, so that's also interesting. I hope that we have not talked about this, but this is not too difficult. But important is now how we assign pointers again. Again, pointers we learned. We use the difference operator. In my case, the number here. Let's start with the number here. The number is my pointer, and I have to use this difference operator. Careful, these asterisks here are not the same. This one is for declaring a pointer, which says this variable name is a pointer and points to a int, right? To a type int. And this one says I am now differencing. Differencing means I'm now getting the value of the pointed of the pointed, not the pointer, the pointed place. For example, this pointer points now to this place, and if I use this difference operator, says I get the value of the pointed place, because we know that the pointer itself has also a value. It is an address, and that's why we use here this address operator, address of operator, because when I print out not here the pointer, we can see I can print out also the pointer itself. So that's very interesting. I hope you know this as well. SDA, let's make it out here fast, see out. Now I can print out my pointer, for example, pointer number. Now I point here this pointer out, and here you can see that this one that this and this one is not the same. This one is also a value. Here, I get the value of the pointer, which is the address where I point to. And here I get the value from the pointed address. And yes, I think that you know this. And when I start, I think we have talked about all the other things in the string is the same thing here. I use here just differencing my pointer again. Here's my string. I take this, we have talked this, then you can difference this one and then you can assign a value to it. So I start this one and let's see what we have. So far you should know all this, and you can see I started here on top with this one, initialized, printed out, yes, expected. Then we go to the reference part. It says here my telephone number, my string. And here it says now here string reference, it changes, and here it changed here the number, and you can see yeah, this is only just other way around, but here the number, the telephone number becomes 111. This is the telephone number, and the name from coder becomes string house. And here we go to the pointer, and here the first line I just added. The first line, like I said, the value of a pointer is addressed. And if we want to know the address value, we use this difference symbol here, and then we know the value. And here I difference the value of this number and this string. And we change this here on top. That's why it says here 222 and string pointer. All this kind of stuff you should know by now. And the reason why I make this just for a fast repetition, so that we can now create our own class. So this is just so that it's not get too complicated, because these classes will become more and more complicated when we have to talk a lot of things. But let's create now our own class. Here we have these examples. I hope you understand all. Let's do it now. So you can see here what we need first. We need to check where my class is in the namespace std house big house. So I know it. So I have Altos. You can see this is exactly similar to this one. Here is our namespace. I write a namespace house. And then here the string is the class. In my case, the big house is the class. And I select this, and you can see this becomes the type, right? This is a type now. Exactly like the string, which we know. And this one is also a type, like I said, but this is a primitive type. And now we give to this big house a name. Let's give it a name. In my case, I call it just my house. My house. But now let's test something here. When I make a semicolon here, this one is not working. But if I would make here a semicolon, let's say here, this will work. And the same goes here for my other one. So we have here already something to consider, at least to consider. And the reason, so you can see here, it will work too. Our declaration works too, but it means not it is good, because it can have only garbage in it. But this one here works. But my class, which I created, is not working. And I said this one here is actually very similar to our one. But what is the problem here? The problem here is, you can see when we hover our mouse over it, it says here no default constructor. With other words, if I provide here a default constructor, I could make this as well. So let's provide a default constructor. How will we provide a default constructor again? Yes, we know, big house, something like that. And we can write here even default, something like that. And almost, what's that? If because I wrote it wrong, that was it. Default. And you can see now this default constructor exists, and we have a problem here, because this now it exists, but when I start, you can see, or you can't see, it works. But the problem, it works. That's nice. But it works. Okay, so we need a default constructor. That's nice. but sometimes I thought they are not initialized, but here I have provided initialized values. Okay, that's why it works. Okay, then let's go on. Okay, we have created a default constructor, but I don't want a default constructor. And the question is now, wait a minute, why you don't want a default constructor when our variable is asking for that, because we can't make this? And the reason for that is this one is my own created class. But what is if you are working with a class which you have not created, which means you are going and get from another class from the library, like this one here, the string, or anywhere else, and they have not a default constructor. And I said to you, what you have to do now is all time, you have to learn to analyze these classes. And if you have a situation like this, let's say this one was made by me and you are trying to use my class, what you have to do now is, if you are trying to use exactly my house class here, is you right click on it, like I said, go to definition, and then it jumps here, and then you check out why it's not giving me a default constructor. You are jumping to the constructor, for example, and say, oh, here is no default constructor. And then you realize, but there are constructors. And then you can say, okay, if I want to use this big house, I have to provide, I have to choose this constructor or this constructor. And then you can choose, and let's say you want choose. Let's make another example where you don't want to use this delegate. You say, okay, I will provide a house. I will provide a house number and a house name. Then after you analyze this one, you go back to your variable. Now you know it, what you have to provide. And let's say it was a house number, let's say 14 or something like that. And then what we have provide as well, we have to provide a string. And you can already see here infos, which is very nice, these tooltips. Just use it. Let's see what we have here. We have here other things as well. You can see overloaded constructors. Interesting is we see here 4. And this kind of things we skip now, because this we talk later what this is, because this is again a compiler created constructors, and we have to talk later about this more. But right now we have only 2 constructors. Let's say we have 2. You can see we have 4, but let's say we have 2 because you analyze that and you see this as only 2 constructors. And this other 2 you will learn, this is the compiler defined constructors, implicitly defined, which we will talk later. Like I said about classes, there are many things to talk, and this is also one kind. So anyway, we are defining now. I said I use the first one where I need 2 arguments. One is 14, and let's say here my house, I provide also a name. And now I can use it. So that was the first difference about this normal variables, that sometimes we can't just use this one. And of course here one more thing. Careful, this one is an assignment normally what I do here. What I mean with assignment. Assignment means, can I use, for example, an assignment like this one? No. We can't assign this one because here are 2 arguments, right? This is not working like this, but we can make something like that. And the normal thing, this one is also not working. This was not it. Okay, anyway, but important is normally you would do this one this way. For example, you can make this way and this one. So this is, we learned also about this as my assignment. This is called this uniform assignment or whatever. You can read it. And this is similar to the other thing with this round brackets. And why I'm showing you this? I mean, this one worked very fine. Why I'm showing you this? And the reason for that is this round brackets here can cause problems when we initialize variables. So what problems can this cause? Because watch this here again. when you watch this kind of stuff, it looks like what? Yes, it looks like a function and not a variable declaration, right? Look this, we have here a type, which is our return type. We have here a variable, and we have here some arguments which call the function. So this one is, let's say, can irritate many people. That's the problem. But when you hover your mouse over it, you can see it says it's a local variable, and then it says it's in house, and yeah, it's a variable. So it's not a function call. But in general, this one can really irritate many people because it looks really like a function. And to avoid this, yes, you can make something like this, for example. And you can watch how to initialize many things. We have talked already about initializer, and then we can see if you can use this one as well, but probably we have to use our overloaded operator here, which we have not talked, and that's why I don't go into that one right now. But important is just use, perhaps we should use now this one, because it's not so that you don't get confused with functions. That's very important, I think, because we can create here functions, right? So for example, let me show you. I can create here house, big house as a return type, and then this is house function, and this house function I make just a int, I don't know, int whatever. But of course I can't define it here, sorry, of course not, but I can declare it here. So let's call it int test, and I can declare it here. You can see this one looks now okay. Let's make here also two values. This is the string name. So you can see this one looks similar. Of course, it's not similar because we know we can't define a function in another function. But still, it looks really, when we compare this one here and this one, yes, return type, this one and this one, but this one has here a color indicator. This when you see a color indicator here, in this case, it's not a variable, it's a function call. That helps, but if you have not a color indicator, then this one can irritate. And to avoid this, so don't worry, you can use both styles, that's what you like, this one or the other one, but careful that you don't yeah, it can irritate a little bit because it looks similar to a function when you have this other way. So I think we should go on. You have realized that as well. The next thing what I have to talk is, all right, now I know I have to analyze this class to understand it if another person provides this, because without analyzing a class we have a problem. And here one more note. Normally we want the source code. Source code means we want the definition where we see the body here, because most time there are programs who are only offer us the declaration and hide the body, and we don't want this, because normally we want to see how this kind of things are implemented, because if we don't see how this kind of things are implemented, but especially for starters, we can't analyze them and say yes, that's good, because who knows, there is a class who provide anyone with a declaration and make here in the implementation something else, right? So you say this is I don't know, a print house. Here I have here a print house name. Declaration providing means you would only get this one here in the header file, but this other code here, the definition in the CPP file, you would not get. You have no access to it, and that is all time bad. And that's it's also called, when you use this kind of term in the net, there is open source code. Open source code means you have access to the definition, so you know what they did there. When you call this print house name, it is really printing out the house name and not any any strange things happens here, the programmer could do something else here, and that means open source code means you have access as well to this definition, and there are many programs out there as well where you have not access to this definition, which means they provide you just this declaration so you can call it or something like that. They show you what you can call, and they made a description on their own in the net, but they don't provide you this definition, which is most time you have to trust them, and that is all time a question, definitively in risky places. For example, in non-risky places you don't care, but if you make let's say you make something a bank account or something like that, you don't want trust anyone who says, I give you a declaration but I don't show you the definition. You don't want something like that. Definitely not. Because this can break your or can cause big problems for you. All right, that's only a side note. We will talk about this a little bit more, but right now you should know we are interested in the source code. We want to analyze the class, and we want to see definitely how this is implemented. You can see my print house name is indeed just printing out my house name. It is taking this name here, and it is just printing out and doing not something like okay, let's get his passwords because he can't see this code, something like that, right? So that's why we watch this code here, that nobody is doing additional crap stuff, just in case that you know it. So we want the source code. We want to see what we are using in general, but that's only a side note. So for a starter, not so important. We are learning, so we don't care at the source code right now. But later in future, yeah, try to get all time the source code if it's available. If not, you must trust, and trust means, ooh, I don't know if you can trust all. So that's that. So let's continue here this creation. So I have created now this house, and how we print this out. Let's print out this one as well as they see out. Now I print out my house, and we will have here a new problem. So my house here, we just took the variables here, right? I took here also the variable. I print it out. And what I get is, I get, too bad, an error. And the reason for that is, we will learn a little bit more that this here, you can see this operator is complaining. This print out, see out operator, and it says here no operator to this matches the operands, which means this operator here is not finds not a function which can convert this one to the C out. We will learn overload operators. But before we learn that, we still need a way to print out something. I think I showed you one way before that, and the way is we have now something here different. The problem is when we go to my class got actually values, right? And they have different values, and that's why this operator says, yes, what you want print out now from this my house. You want print out all only one value, or what you want. Or for example, this string here, this my name, we have already talked. Interesting is here when we go there and make a dot, you can see there are only defined functions, at least public, and that's very important. On the private, we don't know. These are not the private. We don't know what else here is included, but public, there is no public function in this name. And important is this this string here is also this overloaded operator has know exactly how. There is an operator who is, operator means all time there is a function, a special function, which uses this operator to convert it in this form. So later we will learn just one more function, our operator function, which is just converting that what we want when we use this one here with a special class, but later more. And here it works, there is not. But in our case, when I make a dot here, you can see I have here a function, but I have here two variables. So what we want to print out, that's the problem here. And the solution is we have to select it right now. Later we find, when we learned overloaded operators, we will find other solutions, which means, like I said, this operator is just a function and we can assign exactly that what we want print out when it sees this symbol here, right? Then I can say, when you call my house, what you should do exactly then. We can do this later, but not right now. We have not learned this one. Right now, we want print out this special variables one by one. It's not effective, but right now we are starters. We are doing that till we learn the other things. Okay, in this case, I wanted to print out my name. Let's say my house name. Okay, here is my house name. But of course, I assigned also a house number. I could print out this one as well if I want. That's nice. So we learned here already different things with our class. You see it's similar to this one, but yes, we have to learn and consider some things, and we have of course learn more. Let's go and do this fast with this references and with pointer as well. So let's see what we have there. So first of all, we create again the same thing. Again, my house. It's the namespace, I use the class, and this becomes again what? It is the type, like all time. And here I want make a reference now to my type. We use the ampersand. That's all right. Now this one will be a reference, and we make again a variable. And I call a variable name for my reference house. I call it, what is this? My house reference. Referenced. Let's call it referenced. And when I make this one here, you can see, like all time, it makes an error because it is a reference. Reference means we need to assign it immediately, but careful again. This one, let me show you this directly again in a class. When I copy this one and go into a class again, you see this one makes here not problem, but it causes here in the initializer problem. All time when you see a reference in a class means the constructor must be initialized, but the declaration which you see in a header file can look like this one. Okay, that is just a repetition, a short repetition. Why not? That was similar to this string what we made here. And here I have to provide again the same thing like before. L value, right? Which means an L value. Here is again, let's provide an L value, which is my house name, because here important is, no, not my house name, sorry, my house. Because important is that you have to provide also the right type. Careful, not like me who said my name here, that would be a string type. So you have to check this type, of course, and then you can provide the right type to reference it. They must be the same. And here, this one and this one is the same. That's why I need to provide this one here. I can copy this one here and I can assign it here, and it works. That's nice, at least so far. And it looks like it is not working. It looked like there are problems. It says here int. Yes, of course it says there are problems. I forgot to do this one here on top. Okay, that was just this. So, and here, this one looks good, right? But we learned something with const before, right? Do you remember it? I said, if I have a const, I can provide a value for it, which is not an L value. And this one we skip here. Of course, you can use here const with this one and provide a L value, because this one, L value, like I said, means it is a fixed place already initialized, and the compiler knows this storage place exactly, and we can access it. R value was something, but here an R value to create, for example, that works not with a number. And the reason for that is very simple. We have to find now a R value which is of type big house. Because here I showed you this one with this int, I think. And then you could make this or a string or something like that, so randomly created. Here you must find a R value house, which is, yes, if you find one, you can assign it. All right, this one will work so too, so you can make this const. I don't want make it const intentionally. Normally you won't make this kind of stuff all time const, which means especially in functions, we learned this, we want not that the reference is changing the class, which means if I have here created an object and I made a reference, this reference is pointing exactly to the storage place what I change, and that can change it backward. We learned something like that, right? So let's go here and let's what was this again? My house was it? My house. So I hope this kind of stuff you know too. You see, it's a repetition plus addition plus yes, we learn how to use now this user created houses, and I think that's okay. And here let's use also how to change here the values. Yes, here I changed before the values. Here my reference number, this is this int. Here my string reference, this is this one. And let's see how we change now this one here, my house, this my house referenced. So how I change this one? The problem is here. Let's try it here, my house reference, and let's say, I don't know, let's say this one. That will not work. And when I read this one here, you can see no operator matches the operator. Again, when you read something with operator, that means all time there is a operator function, and this function will handle this assignment. And we have not talked about this one. I mean, yeah, we have not talked and created this one, because if you create something like an operator, this one could handle this one. Because a operator is just a function, and in the function body you say what to do when you see a number like a 43 and this symbol here, and then it will handle this appropriately, and then it will not give an error. But right now we have not something like this. The question is, hey, wait a minute, why this class here has it? Because it's probably defined. Because this one has an operator. The string operator, they have it. I showed you, I think, this before, but let me show this again. Here's this my name, right? Or here, let's say, where is this? This one here. Here, in this case, when I make a dot, you can see operators, and look what we have here. There is an operator equal. This equal handles this input here. All right, so this equal operator, I said this operator is just a function, but it says when it sees this equal here, it will handle in a way, if this one is the right argument, which means it's a right string, then it will make this one. And we have to do this one normally for our one too. So later we will learn operators, and then we can, or must be not this equal operator, it can be any operator. Let's see which operator this string had here. So you can see the string operator has this plus equal. We learned this operator, right? This plus equal was with ints, it's different. With int means you just add to the one which you have, the variable, just the thing what you have here on the right side. I hope you know this. Okay, that's a little bit hard to follow because I explained it so bad, but I think you know this operator plus equal. Equal means just an assignment here, and here this is just an array operator, I think, and so on. Right, later we will talk, when we talk about operator, don't be irritated much about this one. So just know we have not defined this one, and our assignment will not work. So what can we do? But I think I already made an example here. What we can do for assignment is we can just get access. We have this object, right? This here is still an object, so this variable name, and now I access it directly, which means here I bought it, and now I have accesses with this member access operator symbol, which is this dot here. And now I can say what I want change. Let's say change. We have here this big house. We can change the number because we can select here. Let's change here perhaps the name. Because a house name. Because now it's not a and here, this one works again. That's how we know it. And interesting is now, wait a minute. I said before we have not an operator, assignment operator, but here I use this assignment operator. What is that? Let me write this name here and then I explain it in a short way. First of all, let's I call it this time referenced house. No, house referenced. Oh, my other way around. House referenced. All right, well, let's make it here perhaps so and so that it's not so. Okay, house referenced, and of course that's it. So what happens here? Here at this point, do you know it by now? Perhaps you know it when you put your hover over it and read this, but probably not. This one looks a little bit strange, but strangely what happened is it says here we find our operator here which is equal, but we have not an operator equal here defined, right? We have not created. I said it before, we have this not here. But I said some hours ago, no, this was a joke. I said it before. I said something like we have not talked about what the compiler is defining implicitly. One thing we talked a little bit, that was the default constructor, because there are cases when you have not provided here a default constructor, the compiler will create a default constructor for you. We learned this, but if you are providing constructors, it will be not created. And the compiler is not only providing a default constructor, it is providing also something like that, what you can see here, an assignment operator, a copy operator is called, or an assignment operator. And this one is just for the classes, for the class inside the class. And that's why we have here this version where I can, where is it? Here. That's why I can use here this assignment operator, and I say, oh, not here, sorry. I'm already with my head anywhere. So here, that's why I can use here this assignment operator. Here I'm in the class now. So here I'm not in the class. Here I am just in at my variable place, and here it's not defined. Here with this dot here, I go into my class. Now I'm in my class, and then the compiler is providing me this assignment operator. Here in this class, this one is from the compiler provided, and that's why you see here something like this std string references to this string operator. This operator, you can see it's just a function, and we will talk about this probably after classes, or perhaps between, I don't know, because classes is so big that we should talk before I finish classes, because this operator will come here up again. This is in classes really included, so probably we will make there a special video between the classes for operators, but just in case that you know. And so in this case I have now assigned to this class, it is a referenced here because I'm in a reference place. That's also very important. This version, it works, and that's nice. And here, let's do this also with our output fast as it is. Say out how we print it out. We just printed out the reference, the variable name. But again, we have here the same problem like before. We have many variables, and we have not defined this operator here, that when it reads this variable name, how it should handle it. With other words, we have not a function who reads this input here, this variable, and then knows what to do. Because of that, we have to use again this access operator here this dot, and then we have to use again one of that what we want print out. For example, in my case, we have changed this house name, so let's print out this house name. And now this one, this operator knows how to print out this kind of stuff. This is defined. Very nice. And when I hover now my mouse over it, we don't understand here anything. Don't worry, because we have not talked about operator, and it is also use templates and something like that, which we also not talked. So don't, you can try to read it, but probably you don't understand this tooltip. And that's why I said also that you should try to understand this easy tooltips. For example, when we have something like this one here, this one, when I hover my mouse over this one, you should try to learn this. You can see it means a local variable. So when I hover my mouse over this one, it is a local variable which I created anywhere. It is in the standard, it is a string which is in the standard library, and this one is a reference, and the local variable name is this one. All right, so the type is as it is string type, which is in this one. This kind of stuff you should learn to read, because when you see later something like this, which becomes more and more complicated, but we have to learn something more that you can read this and understand this one as well. That's why I say try to read also these tooltips at start. They are very simple, which we are using right now, and you can follow them. So with that said, let's continue. We are almost finished. We have not tested this, so I don't even know if this is working, what I do, but I hope it is working. But we will see in a moment. Let's finish this one with a pointer as well. This is our last step. So let's do the same thing with pointers. Let's create our house. Let's create our class. And what is this? This is the pointer class, which I'm pointing to. I need a house pointer. And how I make a pointer again with this asterisk, because now, and I have to declare a pointer variable. Let's call it my house pointer, because I'm a pointer now. I'm not a house. So my house pointer, and that is different to a reference, because a pointer can use this the semicolon here, which is our terminator, and this one at this place here it can use, but we learned that it's not good to use a pointer which is pointing anywhere. So we had learned we should still assign something, a null pointer. I think I mentioned this before, right? Here you can use again this null Peter, and so on. So this one is similar like before, but I want assign it, not a null pointer. When I know where I want point to, you can assign it, and I know where I want point to, I want point to, and I know that I can even use the reference variable if I have something like that, but I want to point it this time directly to the house here, my house. I point it directly to my house. Nice. All right. This is and something is wrong. So I want it pointed to my house, and you know a pointer needs all time address, because the pointer is what? The pointer's value, which is this one, is an address, and we need this address of operator. Okay, we know this already. I showed you this before, right? That this one needs an address. So let's go on and see something new, and which is assignment. So how we assign again? Right, all time we have here my house pointer. Let's copy this one. Let's paste it here. And of course I need again the difference operator like before, because now I'm not interested in the pointer's value, which is address, memory address. I'm not interested in the memory address. When I use this difference operator, I'm interested in the what? Yes, in the pointed value. And here I have again, like all time, the same problem. I have here different values. For example, I want to change my house name to pointer house. And we can see, of course, this is not working. Again, the operator has no clue what to do at this point. We have not created a special operator for this one. And that's why we use the same thing like before. A special assignment we use here. the member, and then we can say, okay, the house name here. And now we see something new. What happens now? I mean, I did this here. It worked very fine with this access operator, and here I have an arrow now, and I have a strange symbol here. And I mentioned this one of my other videos. We have in the class two access symbols, one for pointers and one for normal variables. The point is for, you can see here, this point is here for normal variables and references, which works. But if you are using a pointer, this one is converted to this strange symbol here, which is actually cool, right? This is symbolizing you are using a pointer here. And this pointer means you have created here a variable, which is a pointer. Yes, indeed, that's true, because here you can see I created and declared a variable. It is a pointer, this one here. And this symbol here says I'm a pointer and I point to house name. And when I delete now the first part, this one works. So this is the new thing what we learn here at this point. Here is another access specifier, and this one is made specially for the pointer, and you will see this in many C++ codes because they use this one. But careful, there is an alternative way. And some programmers might use even an alternative way, so you should not irritate it. That's why I show you the alternative way as well. This was the house number. Let's make the house number, because this was the house name. Let's make it for the house number. So again, what I did here again, I get the pointer. I know this one is a pointer. Normally what you can do now is use this arrow sign, and when you do this arrow sign, you see you have again these options like I did when I did this dot sign, and it points out what you want access here. And here, for example, my house number. And then I use again here this assignment operator I can only use because I'm in my class again. Here, when I use this one, I'm in my class and the compiler is providing me an assignment operator. And then I can, for example, write here another number. Let's make it 50. And yeah, but what is the alternative way here? This is the normal way, which you should know. It's very easy. When you see this pointer symbol here, means this one, that's the first one, is declared as a pointer. Then you can use this one. Careful, if you have this one here on top, for example, here my house, right? I declared my house here, here at this point, my house. And if I make this one, it's not working. And you can see it says here something like operator, and now this one is an operator. Operator, or this one is an operator as well, applied to a house being house instead of a pointer type or something like that. Important is this one is not a pointer type, so that's why it's not working, this one. And so you have to use this dot here, and on pointers you have to use this pointer symbol. But careful, I said there is an alternative way where you can use the dot as well, because this dot is normally means all-time access, and this one was implemented with an overloaded operator, because this one you can see this pointer symbol is again called a operator. Operator means all times these symbols, this plus, minus, or in this case the pointer symbol, because I can make it again with a dot, but not this way, because if you make this way it is complaining. What you have to do is you have to do this one, and you have to provide one more thing, because right now I have used the dot. I say I want this one. The step here says I want just access this house number. And you can see it's just pointing out I want just access something. And here, this front here, I want convert to a pointer, because right now you can see I have just used this parenthesis because I need to specify one more thing, which indicates that this variable is a pointer. And how I make this? With a difference operator. And here, this one is the alternative way, what you see here. And normally you will not see it in C++ programs because almost all use this overloaded operator here with this symbol. It's very easy, straightforward, and yeah, you can see it instantly with this symbol. But this one is exactly the same thing like this one here. This one is overloaded, an operator. This one is the long way. And you can see, but it's similar, right? Because here you have the pointer and here you have the pointer. We know the pointer needs to be deference. Deference means you get access to the class, so you are trying to get the value of this class. That's why we are deferencing it here at this point, and then we are accessing it, and then we try to get what we want. So this one, I showed you this version only because there might be people there might be codes out where they indeed use this kind of style, so don't get confused, because there are many things to get confused. So that when you see something like that, you should, most time when you see something what you don't understand, is what you do is you hover your mouse over it and then read the tooltip, and in the tooltip you see what it is really. You can see here when my mouse is here over, yes, here's a variable name, a pointer to a type, more not. So this is that. And here what I have here is the type again string. It is okay, the problem is this house here probably, because we don't know right now when I read this tooltip if this house is a namespace or if this is another enumeration class or something like that, or another class, because we will learn also nested classes. So there are many options. So the thing is, what you can do if you don't know, when you hover your mouse over it, like I said, you should do this, analyze it, go to the definition, and then when you go to the definition you can see, it's in a house, it's big house, and this is just a house which has a type of string, something like that, and then you jump back to your place. And yeah, but this one is the new thing what we learn. We have this we can call it a pointer symbol. It looks like a pointer, right? So an arrow, bing, it points to this one, and I want from this pointer this variable. All right, that's that. And let's make the last thing here. Of course, we can print this out. Let's see how we print out a pointer. And let's see. We have here again the variable. Let's start with the variable and see if we can point it out normal, like we all time try. And like all time we have what? Like all time we have, oh, it works. My pointer, careful, it works. But does it really work? Let's start. And what we see here, and that was what I said you before. Pointer got a value, but the pointer value is all time the address which is the pointed to. That is, the value is this address here. But if you want access the class which is pointing to, or on whichever it's pointing to, then you have to use again what we know it. Oops, you could see it anyway here. This oops, not here. Sorry, we have to use this difference operator, which is this one here. And then we have the same problem like before. This operator has no clue what you want to do, which means we should define an operator, or we are just changing the style here, which means, okay, I say again my access operator, and then when I use the access operator, you can see this dot is indeed working here. But careful, this is just because Visual Studio will convert this automatically in a pointer. Let me show you what I mean. We want print out here the house name, and you'll see it converted here to a pointer. Even I use the dot. That's nice. Again, that's very important. But this is also very nice to know that you can use something like that. But here, this one calls, of course, arrow when you make this one. So if you want to use this style, just use that one. It's very easy. I think you should use all time this style. But This one you will see sometimes too, perhaps, and don't get irritated. Like I said, when you see something like that, try to do all time hover your mouse over it and read what this is, and you can see this is just a variable which is a pointer and points to the type big house, and that's it. And yeah, easy said, that's it. Of course, you should know that this one is also an access operator here. But I think you get this. But in the future we will use all time this one, because this one is the recommended way, or let's say everybody is using it. It's everybody is using this style here, and you should use it as a starter too, because it's much easier, right? When you see this kind of stuff compared to this one looks much easier. All right, I think now we can print out and see what we have, and let's see what we have here. It says here, I'm the default constructor. Is this right? I don't know. Coder, and then so here I create my first telephone number, and then here string. So here these are just variable creations, and here I create object. Here I am, and when I'm here, then it jumps to this. So where is it? It jumps here to this constructor here, and it says here, I'm the default constructor. Yes, you are. And then house name, coder. Yes, because I provided here this one. And 14 is the house number. Yes, the house name and house number I provided here. And this was here initialized. And here important one note, when it jumps to the constructor and it has here arguments like I did here, it will first initialize them, because this one must be initialized before it enters the body. I think we talked also about this one. And that's why I have here coder 14. And then I go here, and then what I did here I print out just the normal telephone number here. Here I printed my name. And here, I think here this house name coder again. So I think this one was one too much. Should make this so. Save this. And now we can continue against. Okay, I think you understand this one. So this one was from here, and the other ones was from here, what we have there. That's not so important right now. Perhaps I should make here also one N to make it distinguish a little bit this kind of stuff, because it's all time annoying. So now it's a little bit better. So this one, this constructor here, this declaration here is the first tab, and all the other things here, this 53, this one here is this part. That was our normal way. Now we go here our referenced way. Let's figure this out. So you can see, first of all, I create here the reference. I go to my telephone number, reference is directly in it here, the string, the same thing here. I make it to this name here, and here I create this new house reference. And interesting is this reference here. What is interesting here on this reference? Interesting is here, we are not calling constructor, and that's normal, right? Because why not? Because we are just referencing. We are pointing to what it's already initialized. The first step here at this line here, it's initialized here one time, and my reference here at this point, this one is now using just this one. I referencing to them, right? This variable is just using that. And that's why we had to reference all time this L value, what I set you, but R value only when you are use const, but there are some other rules. But L value means it's already initialized, and we have a storage place where we can use. Here, this one, so that makes sense. And then we change this a little bit, a reference. Like I said, if it's not const here, this reference means I can change the referenced things, which means I can backwards changing. Backwards changing means I assign here a value, and then you can see the value, the telephone, the print out. When I print it out that my string reference. What is that? My string reference is here. The name becomes to string reference, which was coda before, and the number becomes to 1 because I have referenced it backwards. And why is this backwards referencing so important? I think I mentioned it. I don't know if I made an example, because in functions sometimes they are initializing values with a function call backwards. What is that? Should I show you this one? I don't know, but I can make it. For example, I don't know if I show it with a bad example, but let's see. Let me see if I can include this one. I think I skipped this because that takes too much time. I already talked too much time here. But what I mean is, you can just declare a variable like here, but without initial value, and later you call a referenced function, which is just called later, and then you can assign the values there in it later. So through the function call, because that's why it says you're referencing it. And that can cause problems. Sometimes you want it because you want this backwards assignment, and sometimes you don't want it. Then you are writing const in it, const in front, so which means don't change whatever I reference here. That's why this const is very important in programming. You will see it almost all over the place, this const word, because they don't want that you change anything. Most time they just want to read it because they want to use the value, but most time they don't want that you should change the value. Only in special places they want that you change it. That's that. But let's go here on. So I think you understand this very easy. And here the pointer, how it's referenced here, I changed this one here. How it's referenced, here I put this out. You can see it, it works. And again here one and like old time too much. And here too much too as well, probably. And because I added this one. So then we did this, and yeah, now it looks much better. So, and that is the last place with the pointer. The pointer is here at this point. Here I wrote pointer here. Here's the pointer. And you can see here the pointer is printing out first the pointer, which is our address here. And then I print out the pointer. We changed this. So you can see we changed it through the pointer differencing, writing the pointer value here, writing here the pointer address. And here, let's see the house number. I have not printed the house number out. The number. What's that? Redifferencing and my pointer number. Let me see something. What? Okay. I have not printed out my house number. That's the problem. So I could say that I changed here 2 times. If I would change here the value, because the normal house number is what here? Here's 5, and now I changed it to 15, or it was here 14 even, because the initial value here 14, and then I changed it here to 15. I could print this out, but you know probably what I mean, right? The first, we are using just a pointer, the value of a pointer. A pointer has a value, that's very important. A reference has not a value. What I mean with value, let me show you this one too. Here is the reference, right? And here, well, no, this is the pointer. Here is the reference, right? And I created here my my reference number. And if I printed out my reference number, it is the value of the reference, so never its own. It has no reference value. The difference is in pointer. Here I print out a pointer and it prints out this strange number, this memory address. We talked about this. This is indeed a value. Careful about this. This is a big difference about reference and pointers, because pointers has indeed values. There are many differences, but they are still similar, and has a value. And if we want the pointed value, which we are normally interested, we are most time not interested in this one here, but sometimes yes. But most time we are interested in a value which we point to, and then we are using this difference operator. And here in our new in our own class, which is actually new, we are using this this assignment operator, right, which exactly we want print out. Here we access the class, and yeah, when we learned here, of course you can use here the other assignment operator as well, so just in case, so don't get irritated by this one, because sometimes, like I said, there are people who program in old style or whatever style, perhaps to confuse people. There are also programmers like that, and then you should know that this one is as well as a pointer, which is probably possible too. And here, let's print out house number. Let's see, house number. Do I have a house number? Yes, I have. And then we can see that this one is of course possible too. So you can see here's the number 15 for this one. So that was again a little repetition about yes, what we know about variables again. And this time we learned, I hope, that we can create, of course, a variable about our own created classes. And important is, probably the most important part is that you get used to this pointer thing here. That is the most important part here, I think. But all other things was just a little bit repetition, and again to show you how they are different in different cases. We will do more. I think I stop here. If you have any questions or any complaints like all time, write it in the comments. And in the next video, we will talk a little bit much more about classes like all time. Like I said, classes are big, but there is one more thing what I want to mention. We should make an exercise, because I think this talk about all these classes is nice and fine, but without training we will not understand anything when I go on. So probably I will make in the next video a little exercise again, not a big, so that we get programming practice. Without this practice, like I said, this is just understanding logic, but if you can't use it, yeah, then it's bad. We need practice. So with that said, if you have any questions like all time or any complaints like all time, write it in the comments, and see you in the next video. Bye, good luck, and like all time, don't give up and have fun.